In round one, the formula wrestling challenge was intended to be an introduction to formulas and building out functions. And so you see, we won't get overly complex. A lot of these questions can be solved with one formula or just a couple formulas strung together. It'll get a little trickier in questions 4 and 5, but hopefully as we work through each question, we get a little bit more comfortable with working with the functions, and so they won't be too tough a challenge to take on. So the first question is asking us to average all the times in our data table here. And so what is an average? It is the sum of numbers divided by the count of numbers. And so Excel actually has functions for both of these operations. If I go into the formula bar here, or I could just click in a cell and start typing, there is the sum function. And I'll note that up here you'll see this little box, our formula bar. There is an insert function button here. So if you're ever unsure if a formula exists or if there's something you need to do and you're not sure what functions you have available, you can click that button and search for things like sum. And you see different results that come up. That might be an option. And if you click on sum and click OK, you get a little bit more of a helping window for helping you build out your formula. So wherever you see this little box here, that means the option to go into the grid, into your spreadsheet, and select your arguments. And so I'm just going to select this whole set of data here. This is our sum function. Sum up all the numbers, click OK, and I get a sum. And now the same idea is I want to get a count of our times. And I can just type in count. I see that that is a formula available. Select it all again. And if I close my parentheses and hit enter, and if I didn't close parentheses, Excel would fix that mistake for us. So now I have a sum. This is the total of all the times, is 2,214 seconds. There were 108 times in total. And actually, I'll point out, if I went ahead and selected all these numbers one more time, you could actually see down at the bottom, Excel is giving us the answers. Automatically calculated here is our sum of 2,214, the count of 108, and the average of those numbers is 20.5. And just to confirm, I'll do that calculation here. If we do the 2,000 divided by 108, we get 20.5. So that was one sum function, one count function, and then we divided them two. So three operations in total. But of course, averages are a pretty common thing to do. So there is actually just an average function. And if I wanted to search for average, just to begin with, I could just do the average of all those numbers and immediately get our answer. So I was showing you sum and count just so everyone knows it's there for reference, but actually this can be solved with just one formula, and that is the average formula would tell us 20.5. Moving on to question 2, we need to find the age of the youngest athlete. So we have age in our table here, so what we're really looking for is what's the minimum age. And you probably wouldn't be surprised to see there is a minimum function. I'll actually just hit equals and start typing min, and you see there it shows up. Returns the smallest number in a set of values, and I'll say give me the minimum age. Select all the data here. And there we have the answer to question 2. Our minimum age is 18.28. So question 3 asks, how many athletes were 25 or younger? So I'm going to actually take this approach two ways. I'm first going to show us how we can use the if function to come up with our answer. And then once we understand the if function, there's an even easier solution. So what the if function does, and I'll just kind of slide over to the right here, and I'll say 25 or younger. I'll start typing if. What the if function does is it takes in three things. The first thing is a test, three arguments, I should say. First thing is a test we want to make. And so our test is we want to know if an athlete is 25 or younger. So we select their age, and we say they are less than or equal to 25. That means they're 25 or younger. Now the next argument says if our test is true, what value we should return. I'm just going to say 1 when they're true, 0 when it's false, and hit return. And so you see our first athlete, they were 30, which is not younger than 25, so this gives us a 0. If I copy, Control-C, paste, Control-V, you can see I'm now looking at the next age down. That was a nice thing. Our reference moved down as we copied the formula down. This person is age 21, which is 25 or younger, so we get a 1. And so then if we just copy down, and I've grabbed the little corner of our square there, this is going to keep copying and pasting our formula down. You see I get a bunch of 1s and 0s that basically count up to based off of the age. So since it's 1 if someone's younger than 25 and 0 if they're older than 25, actually we can use that sum function, just add up all our numbers, select all of them, hit enter. And so this tells me we have 33 people younger than 25. Now that was a bunch of conditionals. Each formula in here, I use the if down our table. We can actually consolidate all of this down into just one formula doing all of these tests for us. Not surprisingly, we could search for it. We're trying to count up a number based on a condition. And you see there is this countif or countifs. They're two similar functions. I won't get into the differences between them. It's just about the number of tests you can do. To make things simple, I'm going to use the countifs formula. This will line up with some of the work we're going to do in a second here. If you don't have the countifs formula, the countif formula will also work. It depends on what version of Excel you have. So I want to select a range of numbers here. I'm going to select all of our ages, and for those of you who can't see what I'm doing, actually, when you have a big block of numbers like this, an easy way to navigate it is once you click in one cell, if you hold down the control button as you click arrows down, up, left, right, it'll actually jump down across the entire block of cells that all have data. So I'm holding control and pressing down, and I get down to the bottom. If I hold down shift when I do it, I actually select all of the cells, and so that's what I'm trying to do. I'll jump back up to the top of our data. Let's jump back up here to our ages and say select all the ages. And now our criteria is less than or equal to 25. I click OK. See, I get the same thing, 33, except this was just one formula versus all of these formulas here. So that was question 3, and we can now move on to question 4, a little bit more complex. So question 4 asks for the fastest time for anyone under 25. Now that, the reason I stepped through all of the if formulas on the last question is because we kind of need those to get at question 4. So we're going to do the same thing. We're going to figure out if someone is, the question asked if they are under 25 years of age. So that's actually a little bit different from the last question. Instead of doing less than or equals, I'm actually just going to say check if their age is less than 25. Because the question asks, are they under 25 years of age? So if they are under 25, we want to get their fastest time, which is we're going to combine that minimum function, because we can combine functions just like this. As long as a function returns a value, it can be put inside that other function. So the age is under 25, we'll return that person's minimum time. Otherwise, I'm actually just going to return a blank. I'll do open quote, close quote. And that is, we don't want to return 0, because that might get us confused about who actually had a really small time versus someone where we just entered in 0 because they were over 25. So this is a blank, again, because this person was not under 25. If I copy and paste, we have someone who is under 25, and you see their fastest time is 19.8, the round 2 time. So it's the same idea. I'm just going to copy down this formula across our table, or all the way down our table, I should say. And now I've got a list of times. And now I can get the minimum from this list of minimums. So whereas each row here is showing excuse me, the fastest time for that person, we're now getting the fastest time among all the people under 25, which just so happens to be that first one we looked at, 19.8 seconds. Now, if someone has Excel 2016 and they're an Office 365 subscriber, there was a new formula introduced in January of 2016 that makes this question even easier to do. And that is the Min Ifs function. So it's similar to like the Countifs that we used in the last question, in question 3, but instead of just doing a count if something meets a criteria, we're going to get the minimum if a number meets the criteria. So the way we take that is we do have to actually separate round 1, round 2, and round 3. So we'll get the minimum for each of these. So first, looking at round 1, we'll do the Min Ifs function. So we're trying to find the minimum time for round 1. And we're only going to look, again, same criteria, are the ages under 25. Less than 25. So this is showing us the fastest time in round 1 for someone under 25. I'm actually going to now copy this formula over, and I'll show you if we copy this formula just like this, we're still looking at round 1. We want to make this round 2, column I. I'll just show you first how we would change it this way. And now this shows us 19.8 as the fastest time in round 2 for someone under 25. We want to do the same thing for round 3, and I'm going to actually do this a little bit differently for you now. Excel has absolute references and relative references, and what those mean is essentially when you copy and paste formulas, Excel needs to know what cells to look at. And we see as we copy a formula, in this case I'll copy it down, you see before I was looking at row 20 to row 95, and now we've shifted everything down from row 21 to row 96. By using these dollar signs in our formulas, we can actually lock things in place. So even if we copy down this formula a few rows, it's still looking in the same spot, the same rows, 20 and 95. And you can actually do that same thing to the columns. And so then if we copied left or right, we'd stay looking at the same columns instead of things shifting around. So to make sense of all this, we're trying to find, I'll get this out. This was again, looking back at where it was looking, the minimum of column H, the minimum of round 1, where all the ages, column G, were less than 25. So when we want to do this calculation for round 3, we actually want these column H to change. We want it to shift over, but we don't want the age range to change. We want to keep looking at column G. So I'm just going to do those dollar signs. If I copy and paste, now you see everything has stayed column G, but we're looking at minimums in column J, which is round 3. So that's just showing you, this was a small example, but when you think about like all this copying and pasting we were doing across a big data set, knowing how to use those dollar signs, those relative references, can help you navigate and build out a table of calculations and numbers really quickly. So what we have here across these 3 cells is our fastest time for someone under 25. Now we were trying to look at this performance across all of the rounds, which means, again, we want to take the minimum of each of those calculations. So I will select those 3, and we see that our fastest time, same answer because we're doing things, just slightly different approaches, but 19.8 seconds was our fastest result time for anyone under 25 years. On to our 5th and final question. How many different countries participated? Basically, we are trying to get the number of unique countries in this column here. And if you ran through the data relays, you could see a really obvious option might be, hey, we can just use that remove duplicates off of our country here, and then we'd just be able to count up the number of countries or the number of rows we have remaining. The problem with that approach is it works once. We're totally changing the data. And so if our data then updates, we have new information, we haven't figured out the new count of countries. So we're going to use formulas and functions so that we can dynamically update if our data changes. So again, I'm going to show 2 approaches. One is going to take more functions and formulas to accomplish, but it'll sort of lay the groundwork for how we can actually produce a more condensed formula. So what I'm going to do is, again, I'm going to be using some of the functions we're already familiar with. I'm going to use that Countif formula. So I'll just label this the Countif approach for a second. And what I'm going to do, and I guess I'll use the Countifs since that's what we were using before. Actually, just to mix it up, I'll show the Countif formula. It's not that different. It's just the ordering of arguments, and we'll only be doing one criteria check. Countifs actually lets you check for a lot of things at once. So I'm going to look at the countries, and now I'm going to use that those dollar signs. I'm going to kiss the F4 key. That's going to change this to an absolute reference. You see dollar signs everywhere. The reason is when I drag this around, I still want to be looking at all of our countries. So I'm going to say count if the country equals this particular country on this row. So I hit enter, and this says 3. And so what this is saying is in this entire list from F20 to F95, Jamaica appears 3 times. And so I am again going to drag this down. Our data goes down to row 95, so I'm just going to jump down to row 95 as quickly as I can here. And fill in all our formulas. So there we go. And you can see we've got a count for each country, but we've done this a repeated number of times. Oh, we've got a wide row here, so I'm just going to adjust that and make it a little bit easier to read. So let's find a repeated country just to confirm. So we have Jamaica was in row 20. It's also in row 29. And you'll see if we come down here to row 29, again, we get a count of 3. So we're counting up the number of times each country appears. but we're duplicating our work if that country appears more than once, or we're replicating our work. But that means Jamaica is going to appear 3 times, and so this count of 3 is going to show up 3 times. We can do another little interesting step. If we turn this into the inverse of the count, so 1 divided by Countif, this number went from 3 to 1/3. I'm going to copy that down. And so now we've got the inverses for all of them. And now, because that's 1/3, but Jamaica appears 3 times, we've got Jamaica showing up 3 times, 1/3 showing up 3 times. You add those all up, you get 1. And so what we've essentially done is, by being able to add up all these countries, or all these inverted numbers, we essentially get to a total count that equals all the unique countries. This is a really interesting approach that I hadn't considered until I saw all the work submitted. But it is really an interesting approach to finding our unique values. You would think that we would have a function built in with all of the ones you see available here for counting unique values. One doesn't exist yet, but we do run the user voice site, and I posted a link to it in the blog. If you've got ideas for functions or other features, you can go to that site and to submit requests. We love to see what ideas people have. The things people care a lot about are things we want to prioritize. So this number 48 is our answer, and we could calculate, this would update even if our data changed. But from this logic of taking the counts, using the inverse because the counts will appear multiple times, and then adding it up, we can actually even condense this even fewer formulas. And so that's what I'm going to show now that we understand the logic. So I'm going to do that Countif again, but this time I'm actually going to say check our range, but compare criteria is actually going to be the whole range again. So it's going to kind of give us a gibberish answer, and the reason is this Countif formula is actually doing all that logic we did on the cells before, but it's producing an array of answers. It's producing the answer for each cell, just as we saw way over here. And that big array of numbers is more than can be contained in a single cell here. So the information's there, we're just not able to see it. And so this is a little bit tricky, and I wasn't aware of this approach could be used in this scenario to count unique values, but we did see some of our advanced users here submit this solution, and it made me go out and investigate why it works. So that was really cool for me to learn from the community on these responses. But we're going to use the exact same logic. So we could do a 1 divide. We're still kind of getting weird numbers here. Just know, again, we've built out that array of inverse numbers here, and now we're going to add them up. Now the sum function directly won't work because it's not built to handle these sort of arrays of data sets, but there's a sum product number or function. What sum product does is intended to take a bunch of different arrays of data. Think of a list of a bunch of numbers. This is a really common way to build weighted averages. It multiplies one number from one list to the first number in the second list, multiplies item 2 from both lists, multiplies item 3. So it comes up with basically a long list of products and then adds those numbers together. So if you only feed it one list, it's essentially doing the same thing as a sum. And so that's what we're doing here. We're feeding it one list, but this is a function that can handle those arrays better than just the plain sum function. So when I do this, and it's a little surprising to see, essentially we are doing that sum of inverses of counts, but it's all getting contained just right here in this formula, and just using just these 3 functions, the sum product, the Countif, and the divide we're doing for the creating the inversion. So the answer we get is 71, and the reason that looks so off is, if you're paying close attention, I ran this on the ages instead of on the country. We're trying to figure out the unique country. But that's easy to adjust. We can just click, drag over, click and drag over. Now we're doing the same logic, counting up the number of times each country appears, creating the inverse of it, then adding up that list of fractions, and we get 48, just like we did in our last calculation. So now we have the answer in a really, really compact formula.